So today's lesson is called Problem Solving with Binomial Distribution. Now, let's take, for example, the following equation. X plus y all raised to the cubed. Well, what we can do is we can create our basic expansion table for our Pascal's triangle, and we use the contents of the Pascal's triangle for this level 3 here, as it matches our exponent. So all of the digits in front of the brackets will be in front of each number, and term will be 1, 3, 3, and 1. Now, going from left to right, we start with our exponent for x. So we start with x to the 3, then we go to x to the 2, x to the 1, and then x to the 0 is nothing. Then we start from the right, and we start with y cubed, and then we drop its power again, y squared, y to the 1, and then y to the naught, which is on the first bracket. Now, the positive sign in between here would always be like this. Just keep positing, and we're done. Now, you could also do this problem again, but imagine if I had something that looked like this, e.g. number 2, x minus y to the exponent 3. Well, you'll still use those same coefficients from our triangle, but now you're still going to use the cube, the x squared, the x, and the 0, and then back from the left side, cube, y squared, y, and y to the 0. But we alternate. So if this is a minus, if there's a minus in here, we just put minus, and then we put a plus, and then a minus, and a plus again. And we would do that alternating forever throughout our list until we get to our last term. Now, the reason for that is because of the power of exponents that you find in each term. There's a maximum of 3. So when the y value is raised to the power of 2, you have 2 negatives, you have minus y and minus y, which gives us a positive, and that's why we have a positive here. And the same would happen if we did that for other types of problems. Now let's go on to the basic general term for the expansion of this. So let's say I have the general term. This is what we call the general term of any expansion, okay? For x plus y to the exponent of n. Basically, the general term, I'll call it G. You might call it Q or whatever you want. It's basically given by this, n, c, and then I, x to the n minus I times y to the I. And we use that when we are calculating individual terms that we are looking for. So here's a type of problem that I would like you to be able to do today. So right now we're saying the general term for any specific term in our expansion is going to be given by this equation. The combination of NCI times x to the n minus I, y to the I. We're going to use that to our advantage today. Imagine I'm asking you to find the expansion of bracket x squared minus 1 to the 8 times x plus 2 to the 7, where I want you to find the general term that contains x to the 8. For x squared minus 1 to the 8th, the general term is going to look like this. G sub I is equal to, well, it's going to be 8 choose C of I. So we're going to 8 choose I. And then what we're going to have is x squared to the n minus I, just like we had up top, but n is actually 8. And then we have negative 1 raised to the I. And that's what we have for our first portion of our multiplication of these two exponential expansions. So now let's do the same for the secondary expansion. So we've got for x plus 2 raised to the 7, we're going to come up with a generalized term again. Well, let's call this g little s. G little s is going to be, well, 7 choose s, and we're going to have x to the 7 minus s times 2 to the exponent of s. So now, when I'm looking for the specific term that I asked for here, remember, we were looking for a term that has an x to the 8. When we're multiplying this and this together, we're going to have this massive expansion, and it would be amazing if we could just find the specific term. Because there's going to be times when I ask you for the probability of something that is based on the binomial distribution. And you'll have to use some form of either multiplication, or you would use the basic expansion for that probability. And we could do that with this. Now, what we're going to do, in order to find the x to the 8th term, we literally have to take this problem, g of s and g of I, and we have to multiply them together in order for this to work. So now g of I is given by this. G of I, g of s is literally just going to be this. For a simplification of g of I, we're just going to go and make sure that we expand the x squared to the 8 minus I to get x to the 16 minus 2i. So this will cut down on our calculations for later. So, and then we're going to put in our g of s. And we have this. So now when we combine these two, what I tend to do is I tend to put all my combinations in front. So I'm going to have, let's see, 8 ci and then times 7cs times, well, we have x to the 16 minus 2i times x to the 7 minus s. And then we have our numbers, negative 1 to the I and 2 to the s. So the next thing that we have to do is we have to literally just combine our exponents. Anytime we multiply two exponents, we add them. So now you end up with this. So you end up with this expansion where you have x to the 23 minus 2i minus s is negative 1 to the I times 2 to the 5, 2 to the s. Now, this is our basic term for our expansion. The GIGS is given by this. But I want the x to the 8th term. For this, we have to be little geniuses. And this is what we're going to have to do. For the x to the 8th term, we need to match the 8th power with our general term that we have right here. So we need to actually set 23 minus 2i minus s is equal to 8. Now, once we've done that, what we should be able to do is we should be able to simplify this by taking this 23 over to the right side. We're going to get the following. We're going to get negative 2i minus s is equal to negative 23. Now, you know what? Let's make this easy. Let's go and flip all the signs for all of these equations here, and you're going to get 2i plus s is equal to 23. Now, so all we have to do is find combinations of I and s that will add up to 23. That is what this is telling us. And then we can use that in our original equation that we have up here. So let's continue. Now, when we do some investigating, right, we're going to find the following sets of numbers that give us what we're looking for our I being less than or equal to 8, but greater than or equal to 0, and our s being less than or equal to 7, but greater than or equal to 1. Sorry, I meant 0. And now, here are the 4 sets of numbers that we have. I equals 4, s is 7, I equals 5, s is 5, I equals 6, s is 3, I is 7, s is 1, and this is all found by just simply trial and error. Now, you can pick a number from I and then solve for s, but I tend to just do all of these things as trial and error. So now we're going to use this to compute all of the different x terms and coefficients that go with our original equation that we started with. When we multiplied everything and we got this craziness up here. CIS x to the whatever, negative 1 to the I, 2 to the 5. And so now what we're going to do is we're going to take our time and we're going to literally find the following. So we have for I is equal to 4 and s is 7, our combined crazy multiplication of g and I becomes the following. So we have our 8c4 and 7c7, but now remember we said that all of these calculations were to get x to the 8, so we don't have to do the substitution for that. But now we still have to accommodate for our negative 1 to the 4, because that was our I value, and then 2 to the, 7. So now let's finish off this calculation. So C8 is 70, and then 7 is 1, and then we have an x to the 8, and then we have a negative 1, sorry, correct that to be negative 1 to the 4, which is just 1. times 2 to the 7, which is 128, which means for G4 of 7, we're getting 8,960 x to the 8. So now I'll show you the final three stages that we have to do, because we need G4, we need G5, and then G7 for the second one, and these other ones. And here we go. And for the second combination that we have this. For I is 5 and S to the 7, we have this. And similarly, and for, I guess this was for I is equal to 6 and S is equal to 5. That's what this was for, and that's what this was for. So now we have our final calculation. And for our last set, we get this. Now, you'll notice that all of the x terms that we had a coefficient in front. And all that I'm looking for was the coefficient that started it. So we just have to sum up the coefficients. So to get the solution, we need to sum the coefficients that we calculated. For all the x to the power of 8s we found. And there are 4 terms, and when you add them all up, your term is going to be negative 20,944 x to the 8. Now, the practice problems for this type of calculation are very useful for later on, because I want you to be able to quickly find a certain number at times, okay? And we're going to use a probability distribution that will use this in the end. So I'll leave those questions for you to do online. Okay, and the answers will be provided. You'll just need to show all your work.